MeetEcho has not been transcribing our conversation about Yiddish, Brooklyn accents and all of that. So. So it is the bottom of the hour. It's time for us to get started. In the interest of making the best use of everyone's time who's here, let's do it. So welcome to the CBOR working group at IETF 120. It's correct on the screen. If you had meant to be somewhere else, go somewhere else. If you want to be here, welcome. So Christian, who's controlling the slides? I guess you are. So next slide, please. Okay. My screen is not showing the new slide. So note the note well. That's all I'm going to say about it. You've seen this many times. Keep looking at it. Have some time to read it. It's important. Talks about your responsibilities in participating. And next slide. So this is basically saying treat each other well. Don't be nasty. Don't harass people. If you feel that you've been mistreated in a way that suits the ombuds team, go talk to the ombuds team. And in fact, he's in the back of the room right now, so you can have a very short trip to talk to him. Next slide. As we've been for many meetings now, please use MeetEcho even if you're in the room. There's an on-site tool that you can use. If you use the full client tool, please make sure that your sound is off and you don't unmute. And please get in the queue on MeetEcho if you want to talk, so that you are intermixed properly with Karsten and Christian and all the other people who are remote. So here's our agenda. We're going to talk very quickly about a whole bunch of documents and where things are. And Karsten will, I guess, go through all of those as we did on the last interim call. And then next slide. And then we're going to have a little bit of longer discussion on a few other documents. They're probably not going to be in this order. They'll be in whatever order they are in Karsten's slides, which I reviewed this afternoon but don't remember. And then we'll just verify the interim meeting schedule between now and Dublin. Okay, so Karsten, you're on.
So I just made slides for number 3 on your list. If you want to go through the document status, you maybe should stay on the first.
Oh, okay. So yeah, maybe we should go back to the agenda slides so we can do that. Okay. So Karsten, you want to just run through as you did on the call?
Sure. So I'm hearing some echo, interestingly. That seems to come out of the room.
Yeah. The microphones in the room are very hot. So let me see if turning off my mic helps.
Yeah, it's always a bit confusing to hear echo. Oh, it's gone.
So that made a difference?
And he wants me to turn down the gain, which I can do.
Okay, I'll just use the floor mic up here for when I need to talk. Let me grab it. Go on.
But then you are a very dark figure because the lighting in this meeting is incredibly bad. Okay, so we have 2 documents with the RFC editor, the time tag document, which we started in 2017, if you don't remember. That actually has made it to auth 48. All but one author has approved, and we are waiting for sign of life from the third author. So maybe we need to do some emergency shuffling here. But this should be done within a couple of weeks. Update grammar is in the edit state. So when this is done, we will have a consistent CDDA specification again, because that addresses the errata and a few more details. EDN literal has left the working group and is currently under AD review. And we will have discussion for that. More control has completed working plus call, has a Shepherd report, so we could send it on. We can discuss this later. CBOR Pact, I must admit, I didn't prepare anything because I had enough drafts to look at. So if anybody wants to bring up something that would be great, I have a few slides to jog your mind, but I haven't prepared any questions. So the second item where we probably want to spend some time is CDE, common deterministic encoding. And there are two drafts that are individual drafts, G and H, we could discuss as well. But I mean, there is no rush in deciding. We should really focus on getting CDE out of the door, and then we can look at the other documents. CBOR is not on the working group plate, we have decided. And I think indeed there seems to be pretty good consensus that it's also not an end run around the working groups, so it should be able to go to the independent stream. Modules has one item that we still have to solve, which I probably can briefly report about. It's not yet done, so it's not yet in the implementation and in the text, but maybe we can discuss this briefly. And then EDN EREF, I'm quickly going to touch on EDN EREF when we discuss EDN literal. Yeah, there we need to decide whether we can go ahead with that, but that's meaningless if we can't get progress on EDN literal. And then there is the draft numbers document, which we probably don't have time. And this is interesting because it's something that is in a lot of documents, but it's supposed to be removed before the document is operated on by the RFC editor, so that it's a normative reference that vanishes while the document is being edited. Okay, I think that is that part, and then I will just switch to the other.
You already have slide control. I'd like to jump in briefly here because there wasn't, because we still had the agenda slide on. You sent me a link recently on that you might want to have discussed here on ABNF tooling. I think I'll just move that down to the AOB and we'll address that then, or do you want to talk about that in some earlier plan?
Let's do this under AOB. It's really interesting. It was on the working group mailing list as well, so most people should have seen it. And yeah, maybe we can talk about in the context of modules as well, because it's highly related to modules. Okay, so I hope this time it's not premature to switch the slides. I need to waste 1 minute here. So we had this REDS meeting on Tuesday, and Thomas Fossati was commenting in the chat about the escaping hell you get into when you nest JSON into JSON, and so on. I casually remarked, in CBOR, there is no escaping. And AJ said, oh, that's a good t-shirt. So maybe we will use this little combination here a little bit more in the future. Anyway, just quickly to give some order to this huge number of documents, we have 3 formats we are working on. One interchange format, CBOR itself. which we sometimes visualize in hex, but it's a binary format, and 2 languages that we use to talk about CBOR. One is for CBOR instances, the diagnostic notation, or EDN, where you can describe a single CBOR document in text form, on a whiteboard, in a configuration file, wherever you need text-based representation. And then we have CDDL, which is something that some people would call a schema, which I would probably call a data definition. So it's a data model language, grammar. And that is very closely related to ABNF, and that's why the ABNF issue that came in today that Christian just alluded to is so interesting. Okay, and so we will go through, this is just showing CBOR pretty. We will go through the agenda in the sequence that was on the agenda. So we will do the 2 EDN related items first. Then we go to CDDL more control, maybe because that's essentially a decision to ship, that should be quick. Then we can talk about CBOR Pact, but again, as I said, I haven't really prepared much there. Then we go over to CBOR and look at the deterministic encoding and 2 related explainer documents. And finally, we go back to CDDL with the CDDL modules item. So I just used the sequence here that was on the agenda. Okay, so that was the overview. Now, diagnostic notation. Diagnostic notation is meant to be used in tools, on whiteboards, in specifications for diagnostic output. It's not meant to be an interchange format. So we were very, very adamant to make this clear in the original CBOR specification, RFC 7049. And we were adamant enough that we decided we are not even going to put in ABNF for that. So people really notice that is not meant to be for interchange. So that magic has worked for some 11 years, and maybe it's now time to do the ABNF thing. EDN is, or diagnostic notation, is JSON plus some more functionality. So every JSON text, actually every interoperable JSON text, is an EDN text. So you can just push in your JSON into CBOR tools. The 3 main things we need to add is binary byte strings. We not only have text strings like in JSON, but we also have byte strings. The concept of tags, the extension point of CBOR, and we need to generalize map keys. In JSON, they are restricted to text strings, and in CBOR, they can be anything. So the small print thing you see on the bottom right corner of this slide actually is an example for using diagnostic notation in an RFC. Juan.
Yeah, just a quick clarifying question regarding map keys. So it doesn't appear that there was any documentation prior about what was allowed, but that positive and negative integers and text strings were allowed, and that's what's allowed in various CBOR related registries like the CBOR web tags. Do we have in the wild anyone using map keys that are not integers or strings?
Certainly, the suit manifest specification, for instance, uses arrays as map keys. It's a bit weird to use a map as a map key because maps have this not so great equivalence relationship, and since we want to avoid duplicate entries in maps, it's probably not a good idea to use a map as a map key, but anything else can go there. Yeah, Chris just notes on the chat that he's using arrays as map keys. So I think that's pretty normal. Okay, so that's the background. That's where we are coming from. And in the 11 years since, we have added a few things. So the update with 8610 actually gave us embedded CBOR, a notation to put a byte string of encoded CBOR into an EDN notation, and instead of having to use the hex A10101, which of course every CBOR user can read as a map with a key of 1 and a value of 1, we can actually write that down in EDN notation again. So that's what the double angle brackets do here in the example. We have worked on readability, so we have added comments, which is probably the most requested feature that JSON doesn't have. We have added a new comment syntax as well, end of line comment. So when this says news, we are talking about the new EDN literal document. We now allow a final comma in a map or array. The commas are actually completely optional everywhere. So if you just want to do a vertical listing of things, you can do that, no commas needed. And the big new thing that comes in this document are application-oriented literals. And let me talk a little bit about what these are. We have one extension point in CBOR that not many representation formats have. That's called tags. And these are essentially plugins you can put into CBOR to express some semantics using a structure that you can write down in CBOR, but you assign additional semantics to that structure using the tag. So for instance, if you have a byte string, that might be actually an arbitrary precision number, but you don't know. But if you put tag 2 on top of that, then you know, oh yeah, this is an arbitrary precision integer that uses bytes in a specific way. So that was pretty much an innovation we put into CBOR, and that seems to have worked pretty well. The problem here really is that when you write EDN, you still have to write the representation that the tag uses in its tag content, instead of being able to write something semantic. And on the previous slide, we had an example. So date time, DT 2024-03-22, and so on. That becomes a number, in this case, an integer number. And so far in EDN, you only could write down the 1711 and so on, and had to put the actual semantics into a comment. But that, of course, is error prone. So we were looking at a way to actually allow the syntax that is on the left-hand side of these arrows. So datetime and IP addresses are two obvious things, but we have quite a few more application-oriented literals that are lined up, just not in this document. So we have one piece of syntax that is almost extensible already, which is the byte string syntax. So we decided to simply use the byte string syntax. If you look at the example here, that's okay. I mean, it's maybe not the most beautiful syntax we could have come up with, but I think one can get used to this very quickly, and it works. So we are using the byte string syntax, and each time a new kind of application-oriented literal is being defined, we register a prefix with a specification that says how you turn the text in the single quotes into the information you want to have. And by the way, these not only generate tags, but they can also generate the unwrapped tags, or the naked untagged information that is within these tags. So that is really the innovation. That is how EDN literal started. And we just thought, okay, if you are touching EDN, we might as well do some general cleanup, do the usability enhancements I have talked about, and finally answer the frequent request for an ABNF of the language. So that's essentially where we came from. And examples for further plugins are, for instance, E. The E prefix is used to introduce some constants into EDN. EDN is not a programming language, it's just a data format. So if you have something that needs to be 17, but don't really want to put 17 in your example in the spec, you can use the E mechanism to read this constant out of a CDDL module that you use as input to this. So this is an extremely simple mechanism, but it's actually quite useful, and it has already been picked up in a few specifications. One of the benefits of using this is that when you are using code points that haven't been assigned yet, you can throw in some private use code points or some random squatting code points, which I don't recommend, and get your examples actually machine processable. Instead of what we do today is we write the code points into the EDN, and then we really have to be very careful when the RFC editor comes and tries to understand what we have been doing. Okay, somebody should look at the chat. I cannot both talk and answer the questions. Go ahead.
I think it's sufficient to keep that in the chat. It's part of it is in the minutes. You can pick it from there later.
Yeah. So if somebody
naming those things
reads the questions in the chat and answers in the chat, then I'm fine, and I can always send corrections the next time. So another example that we had is the concise resource identifiers that we are defining in the core working group. There we have a format, which you can see after the arrow on this slide, that essentially contains a parsed UI. But of course, people are not used to writing parsed UIs. They want to use the UIs they write into their browsers. So having an application-oriented literal here, which is called CRI, allows us to notate a URI, or actually IRI, and have the tool generate the CRI representation of this UI. Okay, so these are just some examples. A few more are coming up, and I think we will use this a lot. Okay, so we want to have these application extensions in ABNF, but by definition, because this is an extension point, the ABNF cannot describe yet what is not known. So what the ABNF in EDN literals does is define the overall syntax. So how does an app string actually look like? It's an app prefix followed by a single quoted string, and the app prefix has a certain syntax, and a single quoted string is a single quote and a sequence of 0 or more characters that satisfy the rule single quoted, and then another single quote. So this is generic. It definitely will cover all the application-oriented literals we might be defining in the future, but it doesn't actually define them. So the question is, how do we do that? And the idea was to make the application extensions pluggable. So the overall syntax stays the same for all application-oriented literals. And we describe each application-oriented literal with an additional piece of ABNF that is unrelated, not connected to the ABNF that is used as the base syntax, but describes what the text in the single quotes after de-escaping and what you do in such a text literal in a representation format, what the text actually, what the syntax of the text is. And one reason why this makes a lot of sense is that we have foreseen the situation that an EDN literal parser may not, an EDN parser, excuse me, may not have been upgraded with the most recent prefixes. So you may want to use an existing parser that simply doesn't know what, say, CRI means. And in that case, what you actually get is a tag 999 with the word CRI as the first text string and the de-escaped, decoded content of the text in the single quotes as the second element. So you can have something later in the processing that actually implements the part that the parser, the EDN parser you have been using for some reason didn't provide yet. Okay, so in this case for CRIs, the actual definition is extremely simple because we just have a single line ABNF here. Epsilon CRI is IRI reference. And what IRI reference is, we can copy paste out of 3986, 3987. So this is really useful if you have existing ABNF for the format that you want to use. Otherwise, yeah, you of course have to define your own ABNF as we always like to do. So this is the idea. This, of course, means we have multiple grammars in the document. We have the grammar for the base syntax, and we have per prefix another grammar that tells us what the content of the single quoted string actually is supposed to be per application extension prefix. So an alternative idea, of course, would be to define a way to add the application extension syntax to the base ABNF in the process where we define new application extension prefixes. So that means that the syntax that goes into the base ABNF, that is added to the base ABNF, you're probably using the equal slash syntax of ABNF, that needs to define its own string parsing and escaping. And it also means that from an implementation point of view, the base ABNF changes each time you adopt a new application extension. So they're actually much less pluggable. And also it's really hard to do the tag 99 stuff without kind of falling back to the other way of doing things, which would probably motivate doing it that way in every case. So that's really the discussion. The specification that we came up in the working group uses the pluggable architecture as I described. I have described that as a two-layer approach because that's exactly what it is. many people who have been working with ABNF for a while know that this has been used in other places as well, for instance, in the web linking specification, because there simply are problems with trying to put all definitions that describe both the way something is encapsulated, embedded into a grammar, and the grammar of the thing itself on the same ABNF layer. So that's something that the web linking people learned the hard way. And in the core working group, we unfortunately have used the old version of that specification. So we have exactly the same problems and special case handling because, of course, the mapping was not perfect and so on. So PR 49 is a proposal to replace this with a single layer approach, at least for the 4 prefixes that we have defined in the EDN literal document. So each of these prefixes defines its own single-quoted string syntax. And of course, when we get a new one, we will have to do this in a compatible way. Yeah, there has been a lot of discussion in the mailing list and a lot of arguments. I didn't really feel like I should put all of them on a slide because we will hear them, I think. So let me just summarize the pros and cons, as I see them, of course. So the pros of the one-layer approach is that this is, of course, much more familiar to people who are used to monolithic ABNF specs. So when ABNF was designed in 1977, there probably wasn't that much of an application that would have benefited from using ABNF to describe something that comes out of a parsing process that is described by ABNF. And also people who have implemented JSON or something like that also will have been able to do this with a one-layer syntax. So they also will be more familiar with a one-layer representation. And one other thing is that it's simply easier to share ABNF rules between the base syntax and the syntax for a specific application extension. So if you want to define what a comment is, you might be able to use the mostly the same ABNF rules. So on the two-layer side, I explained, yes. On the two-layer side, I explained why it's actually useful to have true pluggables, so you don't have to modify ABNF in flight while using a tool. But I think more important actually is the isolation between the pluggables and between the pluggable and the base. And that means that we, for instance, can simply use existing ABNF directly. So we don't have to do a new URI syntax that is robust enough that it can be used in a single quoted string. We can just use the existing syntax for existing grammars, I should say. And we don't have to create an error-prone process. Yeah, and we all should be used to using layers as separation of concern. So it really took me by surprise that we were having the discussion. But Juan has had a comment on slide 13, so I'm going back to that.
Hi. Oh, I think, no, sorry, it was actually slide 12. It was this, the tag 999. So, so it seems that if somebody has support for a new tag, for a new app string prefix, and another implementation does not, then they're going to encode to different CBOR, and they're not going to be compatible. So I didn't understand what the advantage would be of adding this tag over giving a hard error during the encoding if a particular particular app string prefix is not known.
The advantage comes in when you have software that actually evolves. So if you do a static photo of your system at any one point in time, there is no advantage. But if you are writing some code that is using a diagnostic puzzle library, and it turns out that library has not yet been updated with a new application literal, then, well, you can fix the library, maybe if it's open source, or wait for that to be fixed. Or, I mean, this is a real deployment hindrance that is coming up here.
So like the example that I'm envisioning here is somebody has a test rig and they have some EDN and they use the EDN to generate some CBOR documents. If the converter to CBOR doesn't fail, then they won't notice this and they'll just be generating CBOR that is not the intended encoding.
Right. So the base configuration of any such parsing library should be not to do this. But there also should be a configuration where an application can say, yes, I know what tag 99 is, and when you, the parsing library, hand me up some parsed EDN, I can handle the prefixes that you didn't know about. So this would definitely be a flag that needs to be set. It would not be the base configuration of the parser.
So this is Pete. Let me preface this by saying a couple of things. First, I have no dog in this fight as far as the CBOR stuff goes. EDNs are just fine. Not EDN literals, just fine. Not my problem. Second of all, the only reason I came into this discussion was because Rowan asked me to take a look at the ABNF that he had proposed, and I actually proposed something different. So if you'd go back to slide 14, the pros and cons. The basic problem I've got, well, let me start with all of this confuses implementation with documentation. There is absolutely nothing about the ABNF that I proposed that cannot be implemented two-layer. It can be implemented exactly the same as what Karsten's describing. And the documentation will have subsections, which has the ABNF for the specific subtypes of EDN literals. And when you introduce a new one, you introduce exactly what the documentation currently looks like in the draft with a new literal. The only thing you add is that app string or equals the new thing, which allows you to update the base should you want to, but you can completely implement the flat ABNF with the same pluggable format. That is not an advantage to changing the way ABNF works. So I think we have to get rid of that. The disadvantage, the con on the doing the two-layer is that things that expect ABNF to be a single complete description of the grammar will fail. What is currently in the draft is not valid ABNF because those EDN literal subtypes don't attach to anything in the overall syntax. They're just free floating.
Dangling productions.
They're dangling productions. And again, what we are doing is coming up with a way to go from ABNF to an implementation that is not impacted by the way the ABNF is written. More importantly, Karsten pointed out back in 1977, but this is not the 1977 ABNF. This is the newer one that came out when we did RFC 2234. The old ABNF was a real parser description, and it had multiple layers of tokens. White space was dealt with outside of the whole thing. You had to tokenize, and then you had to interpret after the tokenization. For better, for worse, I would argue for worse, and I was one of the people who pushed this back when we did 2234. We've got a grammar, this new ABNF grammar is just lousy for really going from instantly grammar to implementation. It has limitations. It has those limitations because we wanted simplification in the grammar itself. That's a bummer. We wanted more specificity, but that's what we ended up with. So what I'm objecting to here is don't start playing games with ABNF to create something that looks like your particular implementation desires when the implementation is not affected by what you're doing with the ABNF. Use the ABNF the way it's designed, and you'll get the same thing. As far as the other stuff that has done this, Karsten pointed me to the RFC. I'd not actually looked at the link state stuff before. It's got unparsable ABNF in there, completely unparsable. It doesn't even have left-hand sides in some of the productions. It's really weird looking. And it was written down for convenience because it was a documentation mode, again, not an implementation description. So overall, what I'm telling you is if you use the ABNF that I showed you, you can do exactly what you want to do, but you'll have a complete ABNF. What's currently in the document is not a complete ABNF description of the grammar.
Yeah, so this is certainly an interesting philosophical point of view. The reality is that the tools that we're using today don't really work very well when you are modifying your ABNF in flight. So you expect, these tools expect to get the complete ABNF for what they are supposed to parse, and then that gets converted into a program that actually uses various mechanisms, these days usually packet parsing, to actually do the parsing.
Karsten, can you clarify something for me? This is Barry.
Yes.
When you say modify it in flight, are you saying that these don't support things like or equals very well? Is that what you mean, or do you mean something else?
I mean that you have a tool that uses a compiled piece of ABNF, and then you add a plug-in that provides a specific application-oriented literal. You cannot do this in ABNF implementations I'm familiar with. You essentially have to recompile the whole thing, make sure that your attributes and annotations and so on still fit in the right way, and so on and so on. So that's one reality that makes me a little bit averse against this philosophical model. The other thing is that the missing link that you have been pointing out actually is a pretty simple relationship. So the name, the prefix, actually goes into the name of the top production of the application-oriented grammar. So that's where the link actually is done. And you already have to do this with any ABNF. So whenever you introduce an ABNF in your system, you have to say where you want to start. So this kind of missing link is completely normal when you're using ABNF. And your criticism of 8288, yeah, that's maybe a little bit too non-traditional for me. But the important part here is that they found out that a one-layer approach really, really, really doesn't work for them. And so they came up with the crutches that they're using to do a two-layer approach. It would be nice if ABNF would at some point support this with syntax. Right now, we are supporting it with English.
I guess my reaction to what you just said is, why don't we just fix the tool, which is perfectly plausible, instead of fixing the ABNF into something that it's not designed for? It's just as easy to tell the tool, use the or equals the same way you would just add a pluggable piece. It makes sense to me. Doesn't seem like hard code to write.
Well, you still have to recompile the whole thing. So that's a bit... The practicalities don't work. So what you describe as a really complicated thing is absolutely trivial in a real-world ABNF implementation. Just extracting the prefix out of the base parse result and finding the right start production to actually look at the content of the text. That's absolutely trivial. Recompiling the ABNF each time new application-oriented literal is added, that's way more complicated, and that's not something I want to support. So I have implemented the whole thing based on existing ABNF parser generators. So it's not like our tools will break when doing that. But I'm not going to write a new parser generator just because I want to make a particular philosophical model of how ABNF should be used work.
So let's go through the queue, because we've got now Rowan and then Christian.
Hi. Okay, so 3 quick points here. So I'm surprised when you talk about recompiling versus not recompiling, because I expect that you have to compile whatever it is that processes the second layer ABNF. So if you're compiling that, I don't see why it's a problem to compile. You have to compile one way or the other, it appears. The second thing is that for me, like, how I stumbled upon this was I read the ABNF and I was like, wait a minute, this doesn't make sense. There are characters in here. I mean, I sent a long email to Karsten. I'm sure he remembers the comment about, you could win the obfuscated CBOR contest or something. I don't remember, something like that. But the reason that I came up with those examples was because I assumed that this was a single layer ABNF. Because that's how other IETF specifications work. I don't think that I would be the last person to make that mistake, even if there was some text note in the document. Finally, the third thing I wanted to say was about so the PR gives the PR number 49, it gives a BNF that has all of this combined, but in between the comments on PR 49 and the mailing lists, I gave BNF that is compatible with that single pass model for all of the other AppString prefixes that I'm aware of other than CRI. And if the working group said, okay, like, yeah, we can go do this way, this PR is accepted, it wouldn't take me very long, probably 30 minutes to go write up, not even, to go write up this for CRI.
Yeah, so essentially you describe an editorial problem. We apparently haven't described this well enough, maybe because it's so natural for some people, which I think we can address by putting in more text. Yes, if you write a plugin, you have to compile the plugin, but you don't have to compile your base tool. So that is a very, very big operational difference, because those plugins are like 5 lines of code in many cases. So it's really trivial to make them available as individual modules. But if they need to integrate into the base ABNF, then essentially you have to make the whole tooling that is attached to the base ABNF accepting of this new stuff. The other observation, it's interesting that you didn't do the CRI, because that is actually interesting. Let me try to find the slide.
I was unaware of it at the time. So
yeah, I mean, that's the point. The point about having an extension point is that people can use it. So we will always have unknown usages of our extension points, and we have to build systems in such a way that the unknown usages work. But this is really interesting, because the AppString CRI can use the single production IRI reference from RFC 3987.
but
Yes.
here's what the comment says: copy and fix more stuff from RFC 3986.
Yes.
Fix, right? So there are things that are broken in many of these old ABNFs that we reference. So you really do, you can't just go and blindly paste something from a document that is, sub 5,000, RFC 4,500 or 5,000, right? You really do have to like pay close attention to it. You have to understand what it means, and you may have to rewrite it.
Yeah, so in this case, we had to make sure that the missing productions that were presumed to be imported from RFC 2234 are there. But I mean, that's something that everybody who does anything with ABNF does all day. So it's not a risky thing.
So I'm glad you said that. Something anybody that does ABNF has to do. So that's like what the IETF has done in the past with ABNF is it uses it the way, frankly, the way Pete describes, which is it's a single layer thing. And so if we're going to go off piste here, we need to have like you can't do it kind of an answer, I feel, instead of just it would be more convenient to us if, because we're doing this for the entire community and for people outside the IETF that reference IETF specs. It's not just for the working group.
Christian?
But basically, my question was just in the direction of what we've been talking to, maybe is continuing Carsten's point. So maybe we have to do some fixes for 3987. But for newer documents where we have, for example, the date time, the update work of the date, those should have up to spec ABNF output. If that is turned into a 2-layer, so in a single layer case, I can just take that, paste it there, and it's fine. For a 2-layer approach, wouldn't I have to start adding the escaping rules, because some of that part might be escapable and can legitimately be escaped because it can be produced by a tag 999 processing generator. So something could generate a single quote literal with some escape in there. So all of a sudden, those 1-layer approaches would have to take that IRI reference or date time thingy, and for every case where there can be, say, a single quote, replace that with a double quote, and for every place where there is a whatever else we can escape, and we can escape a lot of things, it would start having to take that into account, and all of a sudden, I'm taking a single ABNF that may or may not be copy-pastable, but in many cases it will be copy-pastable, into something that needs a lot of pre-processing to really represent what that string would look like before EDN escaping.
Pete?
I said in the chat room, I want to repeat here, the documentation should not be driven by a particular implementation model. And Rowan is exactly right. The reason Rowan came to me in the first place is because he was planning on doing a single pass implementation. This harms his implementation to do it this way. It makes it harder to figure out. You have to do some hand stuff. Someone is going to have to do a little extra work. When Karsten implements it, if you do the syntax my way, he's going to have to put in a little bit of special extra code going, I'm not going to define app string at the top level. I'm only going to use the plugin app strings. And that's how it's going to parse, such that if there's a missing plugin, it's going to fail in the appropriate way. So he'll cut out that one line of ABNF to feed to his automatic ABNF parser. If people do it single pass and Karsten's syntax is used, they're going to have to add a little bit of something. Someone's going to have to do a little bit of work. My concern is we should make the little bit of work be to change the ABNF into something that it isn't if the implementation finds that more convenient. We shouldn't, I'm sorry, I swallowed that sentence. We should make the people who want to change ABNF into something that is non-standard ABNF do the little bit of work, and it's only a little bit of work. Whereas for the other case, we get to leave standard ABNF alone, not implementation dependent. Everybody knows how the ABNF works, and the documentation is correct. So I just don't buy this argument that somehow the ABNF prevents Karsten from doing his particular implementation. Yes, it means he can't just cut and paste blindly, but you couldn't do that in the first place. It's a one-line change that he's got to make to feed into his particular parser.
Yeah, I don't know where to start. First of all, I'm really annoyed by you asserting that I'm changing ABNF. Sorry about that. ABNF is used as designed here. It's just used in ways where we combine multiple ABNF parsers, which you may not have been done in your life before, which is fine, but it actually fits the problem here. But the most important thing here is that when you design something, you think about deployment. You think about how is it actually going to be used? How are people going to solve their problem? Are they going to solve the problem in the way that was prepared, or are they going to do some horrible hack because it's faster for them? So doing deployment right means that you do have to think about ways of doing implementation. And the whole point about the application extension mechanism is that it is easy to add stuff to. And that there are two aspects of this. One is the implementation aspect. So it's really easy to add another parser that just processes the 10 lines or 5 lines of ABNF that is needed to operate on an extracted text string. And you also have to make it easy for the people who write the spec. No sane person will take apart the 40 lines of ABNF for IRI reference and try to make them compatible with a single pass approach. That just doesn't make sense. Of course, people will hack something and it will work in various ways. It will not be consistent and so on. By not creating the problem that you need to intersperse the string escaping with the actual syntax of what you're trying to describe here, you are much more likely to get a plugin that actually makes sense. A plugin specification, excuse me, an application-oriented specification that makes sense. Well,
yeah. So I was going to comment on what you just said and what Christian said about having to having to do work on ADNFs that you include. So I'm going to give an example. So Christian specifically mentioned if there's a character that's escaped that would normally need to be escaped in the generic BNF, but isn't escaped in the thing that you wanted to include, then you might have to go through and add that escaping. And I say, good, that's a feature, because the chance of somebody going and trying to do a single pass ABNF where they miss that subtlety is very high. And it means that, if, for example, there is somebody writes an app string that has an unescaped backspace, backslash, then converting that to a single pass ABNF, someone needs to realize, oh, here is a character that would otherwise be escaped. Whereas if you were just, if you were doing a single pass extension, then if you use the productions that already exist, those productions already have sets of characters that you can reuse, those building blocks that you can reuse that don't fall into those that don't fall into that quicksand. And this is how, we had dozens of specifications related to SIP that added things onto the BNF that didn't cause massive problems for implementers or for spec writers, because you reuse these building blocks. You write things in terms of the building blocks that already exist.
May I just ask a quick clarifying question? So, if I understood you correctly, that would to me imply that someone would build a JSON parser where they basically parse the JSON, and then at some point start plugging in a URI parser into that, because this syntax is inspired by JSON. So is that what you think will happen in this case?
JSON is pluggable. JSON isn't extensible, right? The rules
no,
for
but
JSON
people build extensible applications based on JSON. They just put it into string literals because they have nothing else.
I'm not sure I understand what the issue is here. We're talking about ABNF, the way that it's being used at IETF for the last 45 years. And what I'm saying is, if you want to add a new app string prefix whose contents contains a backslash, that you should make sure that the grammar says backslash instead of just a bare backslash. And if you use the productions that are already present, I think that's a relatively straightforward thing to do. And lots of other protocols have done that, and have done it where the number of things to be added and the variety of new grammars that were added has been substantial. So this hasn't been a huge problem for the rest of the internet community. So I don't see why this is a problem for this working group.
Yeah, but following the example that Christian gave, you would argue that any application that uses JSON to keep URIs should be integrating the URI parser into the JSON parser.
No.
I'm sorry, that doesn't make sense. And
Why?
that's exactly the idea that created the problem for standards like RFC 5988, where they try to do this and they abysmally failed.
I mean, JSON is not extensible, so you have to treat it like a fixed black box. Now, what I'm going to point out here is that if you do this, if you have a code coloring, syntax coloring in your editor for JSON, and then you go and do something that has a bunch of escaped backslash double quotes in it, the syntax colorer is going to do the right thing with respect to the JSON. What you're describing for ABNF, it's going to do something where it's not really going to be correct for somebody who implements a single pass ABNF, which is what the rest of the community is used to doing and what the spec basically defines.
Okay, we have to move on to the rest of the topics. So I had hoped that we could resolve this during this session. I think we have not yet. So let's take it back to the list and put a time limit on this. I'll post something to the list about what our next steps should be. But we do need to resolve this issue to where I can judge some consensus, and I can't right now. So Karsten, move on to the rest of your presentation, please.
Thank you. Yeah, I think we have discussed EDN literal. The next document is the CDDL more control document. CDDL also has an extension point, which is very different from the extension points that we have in EDN, where we can add control operators to the CDDL processors. And we have had an original set of control operators, batteries included, in 8610, and then we have had one in 9165. And occasionally people give us hints that they could write better specs if they had a few more control operators. And this is exactly what happened here. So the main thrust here came from the fact that we sometimes have to include base 64 encoded, hex coded, base 32 encoded, or even base 45 encoded byte string. In particular, if the CDL is actually used to describe JSON and not CBOR, we wouldn't use any kind of base encoding in CBOR, but we do in JSON. So this is a much needed support to enable standards like EAT, which have both JSON and CBOR representation, to share the CDDL code that describes the structure. So I'm going to skip looking at the details here, but it's really useful to be able to say something as base 64 encoded, and in this particular variant, URL, classic, sloppy, not sloppy, hex, lowercase, uppercase, and so on. So that's why these names may seem slightly unfamiliar. And while we were doing these let's encode things in text additions, we found that often people need decimal numbers for something. So we put in a control operator to generate or validate a decimal number. And then people said, oh, I need a 4-digit hex number with uppercase hex. And we said, we are not going to do 10,000 control operators. We will just do one, which is called printf. And we can steal most of the specification out of ISO IEC 9899. Then we also did a .json control operator, and finally a .join that can be used to assemble longer pieces of text or even longer pieces of byte string out of components. So this has received quite some feedback. For instance, we had something about deterministic encoding in there that is now in a different document. So I think it's pretty well analyzed by this point. We had a working class call in March, and throughout deterministic encoding, clarified the strictness requirements, fixed some very unclear text about .join, and finally we now have a nicer table 1 that actually gives you the data types. We also have a Shepherd report. Thank you, AJ. And to me, it seems we should ship it. Does .json escape unescape double quotes? It does everything to represent the data structure that is on the right-hand side into valid JSON text. And usually you have to do something with your quotes. So yes, is probably the answer.
Reopening.
Oh, yeah, I've just been, yep. Thanks, Christian. So the queue is open.
Maybe I should show the table so we can see the whole picture. Okay, if there are no other questions, I think I would like to hear from the chairs what they plan to do next.
Yeah, well, if nobody expresses unhappiness with where we are, given the state of, given the maturity of the document, then we're done here. So.
Yeah, this is a relatively simple draft. I actually timed implementing it. It took me 2 hours and 45 minutes. And this took so long mainly because the base 32 library I was trying to use didn't work. So that's what you get from using library. Lawrence.
Okay,
Yeah.
so then, well, let's hear what Lawrence says.
Yeah, I used this to verify all.
Sorry, Lawrence, I barely hear you. Can you please speak closer to the mic or?
Sorry, is that better? Yeah, I used this to verify the CDDL in EAT, which, you know, and the descent through the base64 and into the JSON and all over the place. It worked really well. It caught a bunch of errors in the CDDL in EAT that was really valuable. But it did take me more than 2 hours to do that. So,
Two and a half.
It's good for me. I'm fine with it.
Thank you.
Okay, so so this moves on. This moves ahead then.
Thank you.
Yeah.
So the next one is packed, and I'm not entirely. Oh, .abnf is in RFC 9165. Is that the right number? Probably. So the previous kit of control operators that we published. Okay, CBOR packed. There is some pretty interesting thing going on here, which I'm not going to describe in detail, but the point here is if you need data compression, you know where to find it. That's not something that this working group has to work on. However, in a constrained system, it's often difficult to do data compression because compression decompression means copying data, and you may not have the storage to do the copying. So it's interesting to have something that is a little bit like compression, but operates on CBOR data that actually are sitting in your packet buffer. And that makes it much easier to actually use compressed data in a constrained system. So that's what CBOR packed is. The draft defines 3 things: a reference set, number of tags, and also simple values that are used in place as stand-ins for reference data. So if you are using some string twice, you might want to put this string into a table, I will come to, and use something from the reference set to reference that string. Then the second thing is we have defined reference semantics. So what I just described is the shared semantics, but there are also argument-based reference semantics. So you can actually concatenate things like a query would do. So queries are kind of covered by CBOR Pact. And we have something called function tags that actually provide an extension point for the reference semantics. And then the third thing is table building tags that build tables that you would use in those references that I have described. So the table building tags are likely to be application specific. They are a natural extension point of CBOR Pact, while the reference set and the reference semantics, with the exception of the function tag extension point, are probably going to stay at base. So we had one remaining issue, and we need to get around to deciding what to do there. You might have an unpacking error, and how do you hand an unpacking error to the application? Of course, you can do it using an API in some form, or there might be a standard representation that you can evoke if you want to. So that we have to look at that. There also is another draft AMSYS CBOR Pact by reference, which provides another form of table setup. But we can progress this draft independently. We don't have to wait for this draft to be ready to integrate it, because we have the table setup tag as an extension point. So that's the current situation. We all have to polish our implementations a little bit more. We may want to do a little bit more text polishing, but this is essentially done at this point in time. So the part that I didn't prepare properly here is I didn't look at the working group last call and whether we made too many changes since.
I did. I had the look there. We wanted to go for another working group last call, but there were in the latest interim we talked about this. Still hands on, like the updated is not yet ready for a later working group last call. But I didn't when later asking, I didn't get any feedback on which parts need updating. So I'd like you to ask you to like, is there someone who has off their head who has a comment immediately, or on the maturity of this not being ready for working group last call? Otherwise, I should start a very short show of hands on like whether the remaining issue has been fleshed out or not.
Yeah, I think the timeline here is this summer.
Yes. So if like I also don't see anyone lining up for the queue. So if you could just, especially if you have any objections to this going to working group last call, if you know of anything that would stop that makes this unsuitable for last call, please tell me. Otherwise, we'll start a working group last call and then continue from there.
So this is also the implicit how many people have read the draft question.
Or people trust others who have read it. AJ?
I haven't read it recently, so I'm just going to clarify there before I embarrass myself. When I read it, I was excited and enthused, and we'll reread it. I don't oppose a workgroup last call. I think that's a good idea. That being said, don't remember the last time I read it in the last 2 months so concretely, so maybe I'm the worst kind of opinion in support of that, so I'll let others speak up too.
Yeah, and we do have the last call, so if we find something, we can fix it there. Good.
Okay. Whoever raised that no last time is either not in the room or it has been resolved. So let's go for working group last call and ship it once that's done. Thank you.
Yeah, but we do one revision, right? So
yeah, but that wasn't the title of the show of hands. So unpack error has to be fixed, but that can be probably even fixed in parallel with the others. Yep.
Good. So let's use the last 10 minutes for CDE. Deterministic encoding. When we defined CBOR in 2013, we were really not that interested in supporting deterministic encoding because so much nonsense has been done with that in other representation formats. But we put it in because it's a feature that people want to have. And 8949 tightened this down a little bit. It's now defined in section 4.2 of 8949. And it actually employs preferred serialization, which is just something that we recommend a CBOR encoder does. And now we no longer recommend it, we require it, plus add a few things. And one of the things is that you actually have to sort the entries into a map to actually get a deterministic encoding result. But all this happens at the serialization level, and of course you have to do the whole deterministic thing at the application level as well. So when we defined the section 4.2, we actually left something open for applications to decide how they would want to have their more esoteric data encoded. For instance, floating point numbers have some interesting things like NAND payloads and so on, which, yeah. So at this point in time, looking at the documents, a generic deterministic encoder is not fully standardized. So that's the background situation we were in. And what we try to do and what the DCBOR activity essentially pushed us to do was to define a common deterministic encoding that would actually push all the remaining leeway that was needed up one layer. So I'm sorry, I'm talking about layers again. Essentially, an application has to decide whether it sends timestamps as integer seconds or as floating point numbers with fractional seconds. That's not something that CBOR can solve for you. So we will always have these kinds of decisions at the application layer. And we managed to squeeze out the somewhat overextensive variability provided by 422, nail some things down and put the rest into the application or an application profile. So we actually defined a term called application profile. This is essentially a defensive term. So why do you need something defensive in your architecture? Well, because people are going to do something that is worse if you don't provide it in the architecture. So this doesn't mean that we want to see application profiles left and right. But if people are somehow unhappy with CDE because of something that happens the layer above at the application, they can define an application profile. And actually it turns out that DCBOR is exactly one such application profile. So that's why we at some point found out we have to crystallize that and put it on top of CDE to arrive at a single common CDE. But I can understand that some people in this room don't really want to give that much space to the concept of application profiles. I just think that the reason why we are doing this, which is to really encourage people to come up with a single, to implement the single common deterministic encoding, that is damaged if we don't provide this emergency valve called application profiles. So this would be the point where Lawrence goes to the microphone, or?
Yeah, so I'm gonna step back a little bit of background here about the way I think of this. So there's base CBOR where you're not there's just CBOR where you're not specifying any kind of serialization or anything like that. It's the core rules of CBOR, for example, no duplicate map keys. So on top of that, you have preferred serialization, which is I think something, and now we're discussing also about whether this is going to be called base serialization or what. But for the discussion here, I think preferred serialization is actually really important. I mean, if you're just designing a protocol like CWT or CenML or SUIT or TEAP or something like that, and you want to make sure it interoperates, you're going to say, let's all use preferred serialization, and you're going to do all right. So to me, that's like 99 out of 100 use cases that are going to want that. So that leaves like 1% of use cases that need determinism. And I mean, I can think of only 2 examples of determinism that I know of. I mean, maybe I do others, but one of those examples of determinism is DCBOR. The other is the little bitty part in the internals of COSE where you derive the structures that you need to feed into the algorithms, not the payloads, right? So, so if we were to do profiles, so for me, CDE is hardly ever used, and something like DCBOR is the incredibly specific use case of, so much so that we're really kind of pushing it off out of this working group. Hey, I'm not questioning the use case. I just think it's a very specific use case that is out there. So if we're going to do profiles, if we're going to introduce the notion of profiles in CBOR, why are we doing it for 1% of the use cases and not like all of the use cases? So, and why isn't CDE itself a profile? You mean you're building profiles on top of something that probably should be a profile itself?
I can answer that question. It's not a profile because you don't want other profiles to exist at this level of the layering. Otherwise, we would have called it common deterministic encoding profile.
Right. So you're making the defensive argument that you don't want people to invent all sorts of stuff. And I'm not really too worried about that because we've only really seen the only real example so far is DCBOR, and it's been actually to me it's a reasonable example. It's a reasonable thing to do for a very specific use case. But we don't. It's not like we have in all the years of 10 years of CBOR and CDE. It's not like we've had a bunch of dumb proposals where we need this defensive mechanism here to keep them at bay. It just and the other thing for me is that Section 4 and Section 5 of RFC 8949 are, there's a lot of concepts in there, and that's the hard, those sections are hard for me to read. Even parts of those things are kind of confusing, like, preferred serialization is defined in 4.1, except for in 3.4.1, I think, on big numbers. And so you get caught out on this, and there's generic decoder. There's so many concepts here of things that it's hard for me to
we have a minute and a half left, so
okay.
please wrap up.
So I really am not enthusiastic about introducing another concept in CBOR, this notion of profiles, especially one that is just narrowly defined.
Yeah, I think Lawrence just explained my next slide. So CDE has been pulled out of the hat by some people to say we can use this for variability reduction, which is a good thing if you have partial implementations, constrained implementations that don't support the full CBOR specification. Then you want to know in your encoder what you should generate to satisfy these partial implementations, and vice versa. If encoders do that, then decoders know which parts they can leave off. So CDE does this perfectly because it reduces variability to exactly one encoding, but that comes at a price. So we decided we wanted to have something that is just on this variability reduction scale, which is at the bottom of my slide. But it turns out that preferred serialization is a little too weak because we probably want to exclude indefinite length encoding from this very constrained variant. So we now have a hierarchy of general CBOR with preferred serialization, which restricts the encoder a bit, basic serialization, which restricts it some more, but at a relatively low cost, unless we are talking about streaming encoding. But for the normal encoder, this will exactly be the same effort doing the preferred serialization and the basic serialization. And then we have the deterministic encoding, which incurs the additional effort of map ordering. And then you can add application profiles on top of that, but that doesn't change anything about the CDE layer here.
Okay, we are out of time. Let's, Chris, very quickly say what you wanted to say.
I dropped it into chat, but basically, I'm doing basically exactly what you're saying here. I'm using CDE for variability reduction, and I am modifying the CDE in exactly the way you are proposing to not require map ordering. So I have at least one specific use case where this is valuable. I don't know that it necessarily justifies application profiles, but I'll bet we can find out on a list.
Okay, so we're a minute over. I think we just need to take this to the next. Can you quickly put up the agenda again? So I just want to go through the interim dates quickly before we shut down. And one more. Okay, so we start on the 21st of August with our first, and then we have 2 dates in September, 2 dates in October before the Dublin meeting in early November. We've already cleared these dates with the core working group, so we're doing our usual alternation. And so let's continue any discussion from here on the mailing list and at the August 21st interim. Thank you, everybody, for coming. Karsten, thanks for being a remote participant. And same with Christian. And hope we'll see everybody in Dublin and on the interim meetings.
Thanks, everyone. See you. Have a good trip home.
Bye.
Cheers.
Barry, just for coordination, there are a few items that I'll probably want for the minutes to double check with the recording. I'll leave this open at my side and then upload it when I'm through it.